Hi guys, so pardon me. We're gonna finish the page, the notes with end behavior, okay? And it's on. This is the last slide of the third page. It says 3 at the bottom. So we're gonna talk about end behavior, and end behavior is different than increase and decrease, because increase and decrease you always go left to right. It's like reading a book. But end behavior has to do with what do you do as you go to the left, and what do you do as the graph goes to the right. So you actually go out when you look at end behavior instead of left to right, like what we were doing in increase and decrease, okay? So I forgot to put a blank right there, but we're going to fill it in. And it says, the end behavior of a graph describes the far left and the far right portions of the graph. So what is the graph doing as it goes to the left forever and to the right forever, okay? Using the leading coefficient and the degree of the polynomial, we can determine the end behaviors of a graph. This is often called the leading coefficient test. So leading coefficient is the number in front of your variable that has the highest exponent, and the degree is the highest exponent, okay? And you're going to get practice with that, so that's not a big deal. Okay, so let's go to page 4. Okay, so here are the notes. It says, sorry it took so long. Okay, so it says, first determine whether the degree of the polynomial is even or it's odd, okay? So the degree is the highest power. So when you look here, the highest power is 2. So that means that the degree is 2, so it is even, okay? Next, so first thing we do, next thing we do. Okay? Determine whether the leading coefficient is positive or negative. So leading means the highest power, the number in front. So this number in front is a 2. So the leading coefficient is 2 again. So that's the power, but that's the leading coefficient, and it is positive. Okay? And some of us, it depends on which class you're in, we talked about how if the variable that we're looking at is positive, it points up in a direction. And then if it's negative, we talked about how it flips, okay? So that's why we care about positive or negative. Even or odd tells us that if it's even, how many directions, or whether they point in the same direction or whether the ends point in opposite directions. Okay, so that's the first setup. So now, okay, we are going to look at this problem, and we're going to use what we know about x squared. Okay, because we already know what x squared looks like, so we're going to use that to help us understand deciding some of these parts, okay? For example, the degree of this is a 2, which is even. Okay? The leading coefficient is a 1, which is positive. Okay, so the end behavior, let's look at these and let's talk about what the end behavior would look like. Well, we know that x squared is really just the graph like this. Okay, so when you look at the graph, end behavior is really easy. As it goes off to the left, which we know is negative infinity, it's going up. Okay, which you can think of the y-axis as negative infinity and positive infinity as well. Okay, so as it goes off to the left, it goes up. Okay, so as x approaches negative infinity, that means left, the function approaches positive infinity. This negative infinity means left, and that positive infinity means up, because x is left or right, but f of x is up or down. It's the y value. Okay? So then, as x approaches positive infinity, as it goes off to the right, the function approaches positive infinity again. So as it goes off to the right, because that's positive infinity, it's still going up. Okay? So the ends of this graph are both going up. And so the end behavior of x squared is positive infinity on both ends. Okay? So if the degree is even, that means that they point, even means that they point in the same direction. Okay, so in this case, they both pointed up. Okay, they both pointed up. The leading coefficient, if it's a positive leading coefficient, that means that the right end goes up. Okay, so if it's positive, that means that the right side points up. Okay, so if we know that the right side points up in this graph, and we know that they're going to point the same direction, that means the left side also goes up, so it's positive infinity on the right and positive infinity on the left. And we'll keep practicing that with some of the other problems, okay? But I just wanted to use x squared because we know what that looks like. All right, so let's look at the next one. All right, so negative x squared. Okay, we're going to use the same rules, but we're going to compare it to what we already know. Okay, because we know about negative x squared already. So let's just use the rules that we're talking about. The degree is 2, so the degree is even. Oh, yeah, I guess you can see that. Degree. Okay? The leading coefficient is negative, though. Okay, so that's the leading coefficient. Okay? So, since the degree is even, that means that they point the same direction. The ends are going to either both point up or both point down because it's even. Okay? Since it's negative, though, that is what tells us, well, do they both point up or they both point down? Well, since it's negative, that means that the right points down. Okay, so when you see negative, negative is always referring to the right side. Okay, so since the right points down and they're going to be the same, that means the left is also going to point down, which makes sense because we know that negative x squared just looks like this. So if that's the graph, we know that it's x squared and just flipped down instead. So they're both going to point down in the end. Okay, so the end behavior looks like this. As x approaches negative infinity, which remember that means the left, the function goes down. So, negative infinity, this is also negative infinity. Positive infinity, that's also positive infinity. So as it goes left, it's pointing down. So it's approaching negative infinity. Okay, as x goes off to the right, because that's positive infinity. So as we go to the right, it's also pointing down. So the function is going down. So this is what it's saying. The right points down and the left points down. They both are going to go down, whether we're looking at the left side or the right side of the graph. So you don't have to graph it, but graphing it helps us see it's going down as we go left and it's going down as we go right. Okay? All right, so the next one. Okay. Oh wait, wrong one. Let me scroll. Okay. So the next one is x to the third. So again, we want to look for the same two things. Relate it. We already know what x to the third looks like, so we're going to relate it to make sure it makes sense. Okay, but again, you don't have to know the graphs, but knowing the graphs helps you be careful. All right, the degree is 3, because that's the highest power. So the degree is odd in this case. So since it's odd, that means instead of pointing in the same direction, the ends are actually going to point in opposite directions. Ends point in opposite directions. So if the left is going up, the right's going to go down. If the right is going up, the left is going to go down. I don't know if I said that right, but that's okay. All right, so that's because it's odd. The leading coefficient is 1, so that's positive. And we've already talked about how positive means that the right side points up. So if the right side is pointing up and the left side is the opposite of that, that means the left side is going to point down, which we already know. We know that x to the third is a graph that looks like this. That one points up and that one points down. We know that graph, so that makes sense. The odd makes them go in different directions, and the positive makes this one go up, and that means the other one has to go down, okay? So then the end behavior is, again, negative infinity, positive infinity, negative infinity, positive infinity. So as we go to the left, as x approaches negative infinity, as we go to the left, the function is going down, so it's going to negative infinity as well. Oh, and we don't want equals. We use an arrow, that means approaches. As x goes off to the right, so it approaches positive infinity. As it goes right, it goes up, so that's positive infinity. So the right side points up, that says right side points up, and then that means that the left side has to do the opposite, so the left side points down, okay? That's what that means. So let's see what else we have. All right, I think we've got one more, and then that last page or that last slide we'll do together in class. So let's look at the last one on page 5. All right, so here's the last one. Okay, so the degree is 3, so that's odd. So remember, odd is opposite, okay? Just think of those O's. Odd is opposite. So odd is opposite directions. Okay, and, pardon me, the leading coefficient is negative in this case. And negative, we know, means the right goes down. It's going to start pointing down instead. So this is x to the third. We know that that graph originally goes up and right, down and left, but that negative flips it, so it actually goes up and left and down and right. So that's what we're talking about. The right goes down, and since it's an odd degree, that means that the left does the opposite. So since the right goes down, that means the left goes up. So negative infinity, positive infinity, negative infinity, positive infinity. So as we go to the left, as x approaches negative infinity, as we go left, it goes up. So that means the function is going up. It's going to positive infinity. And as x approaches positive infinity as we go off to the right in this graph. The function is going down, so the function is going to go to negative infinity. So this means left goes up, right goes down. Okay, so remember, x is always the left and right. The function is always the up or the down. Okay? So that's end behavior, where you're looking at the ends and what they're doing, rather than looking in the intervals like we were doing in the first part. Okay? So that last slide we'll do together in class, and hopefully that'll answer some questions and clarify some things a little bit more. All right.